Waiting for the recording to start. Yeah, it's late. Yeah, it's late in the day. It's just after 4:30 p.m. on Monday. This is 5.07 day one lesson. Here's a bar on the screen. Feel free to pause this to work this out yourself, or just wait for the answer. This is review from Unit 3. Just a little reminder of the domain restriction that's kind of built into your calculators. So I ask you about sine, cosine, and tangents. And I gave you the picture kind of gives it away of the domain restriction here. So sine, that domain restriction is from negative pi over 2 to pi over 2. The domain restriction for cosine is from 0 to pi. And then from tangent, it is from negative pi over 2 to pi over 2. And those are asymptotes, so it's parentheses. So just a little reminder. And that's because if you type, so what we're going to learn today, if you type in like inverse tan of stuff, it's going to kind of default to, well, the domain restriction. And that's important to know and understand to adjust accordingly. And we'll see a bunch of examples that we'll have to do that. Oh, we got a lot of slides. All right, so multiplying and dividing complex numbers from polar form. So our goal is to, well, multiply and divide the complex numbers in polar form. We're also, okay, again, we're going to be recorded. And we're also going to cover these things here. So we need to be able to convert between polar rectangular form of a complex number. We'll learn about that today. We'll multiply complex numbers in polar form. We'll also divide by complex numbers in polar form. And really, these are pretty easy. It's the conversion that is can be tedious and a lot of work, but really multiplying and dividing is pretty simple once you're in polar form. We will not be covering converting between polar and rectangular, from and multiplying or dividing. All right, complex numbers. Now, I think this is new. Well, actually, this part's not new. So, in rectangular form, a complex number we know that is in the form of a plus bi. We know that, right? A complex number in rectangular form is a plus bi. We've been working with those all last week, right? Yep. All right. So, something that is new today would be polar form. So, again, so the a plus bi, this is in rectangular form, just like y equals mx plus b is rectangular form. So rectangular form, complex number a plus bi, and polar form of a complex number, that's in the form of r times cosine theta plus I sine theta. And we usually represent that by like z equals. But this is the piece. So a plus bi will convert into r times cosine theta plus I sine theta. Now, this big piece right here can be written with less, I guess, letters, which is right here. So whenever you see RCIS theta, this piece right here means the same thing as this, I guess, expanded piece. They mean the same thing. And your text, your modules, and even my examples will show both ways. They mean the same thing. Is that clear? And usually it's looking at it like this is way easier. It looks like there's less to do in the problem when it's written, well, with less stuff. But they mean the same thing. This is the R, this is the R. The C is the cosine, C is the cosine. Theta and theta, these are always going to be the same value. And that's why they don't have a theta kind of in the middle here, because this theta right here is going to represent this and this angle. And then there's your I times your sine of theta. So Yeah, there's just less writing, but yeah, these mean the same thing. And I believe so like your modules like it likes to do like the expanded form a lot. And same thing with your quiz, but then I noticed on your test they like said, "Oh, forget that. We're going to write everything in the shorthand form." So just be aware they are the same. All right. I emphasize it enough, right? Everyone understands that. Okay. All right. The two equations that we need to know to convert from rectangular to polar, well, would be these. Um, and I'm pretty sure we learned this last week. R equals square root of a squared plus b squared, and theta is inverse tan of b over a. So there's your b value, there's your a value. Did we do this last week? I feel like we did. I don't. We did. Okay. All right. So this should be review. Okay, good, good. So just review of the two equations. Uh-oh. Shh. Loud dogs. All right. All right. So for example, when you have your complex number written in polar form, so you have your r is 4 cosine theta plus I sine theta. That 4 should actually be an R, not a 4. I don't know. Whoops. Yeah. So on your notes, cross this 4 out, and this should be an R. I think I got carried away with myself with my example that's below it, and I just copied that 4 here. I don't know why. But yeah, that should be an R, just to show that these are the same. So for example, I could write my complex number of polar form with 4 times the cosine of pi over 3 plus I sine pi over 3. Or to make it look just, I don't know, tidier. Is that a word? Tidier? We write it in the shorthand form as 4 CIS pi over 3. No, don't cross that out. This is okay. This is my example. This line's my example. This is the actual formula that shows all the parts. All right. So hopefully everyone sees, you can pause this, that this long expanded form is the same thing as this short form. All right. Is that clear? So, all right. All right. So here's 4 examples. We want to write all of these in polar form. Now, did we do this last? I feel like we did this last week. Did we do this last week? No, we didn't. Okay. All right. I think I've been doing this so long it all blends together. All right. We didn't do this last week. All right. So we want to convert this into polar form. So again, going back to the previous page, these are the two equations that we need to convert. All right, so here's your A value, here's your B value. Go ahead, and if you're watching the recording, go ahead and pause it to write these down. I'm going to have the work and these problems individually on their own page coming up here. Okay, rectangular coordinates to polar. All right, that's why this looks so familiar. All right. So a thing that you need to be careful about, and I did talk about this last week, you need to see on the Argand plane, it looks like Cartesian, right? You have the x axis is actually the real axis, and then your y and the Argand plane is actually the imaginary. So you need to, when you do these problems, you need to look at this and determine which quadrant this is in. So -2 rad 3 plus 2i. What point is this in? This is in quadrant 2. Yep. So yeah, it's in quadrant 2. We're just doing a little note to ourselves because the answer that we get in polar form should also be in quadrant 2. So it's good to write it down. Where is this at now? Your polar point should also be in quadrant 2. If you don't write this down, it's very easy to get an answer, and your answer may be like in quadrant 4, for example, and that happens a lot. All right, so to find the radius, remember it's the square root of your a squared plus your b squared. So we're going to go ahead and set that up. Looks like that. Then you can do it by hand, or you can just type it in, hit enter, but make sure it's in radical form. If you're a fast typer, what do you get? What do you get for your R value? Four? I think four sounds kind of right. Yep, four is correct. Yep. So if you did your work by hand, that's what it looks like, or you can literally just type that in as you set it up. Just make sure that if you did type this in, you put this entire piece in parentheses. If you just put in -2 rad 3 and then squared, without the parentheses, your calculator thinks that you are only squaring the rad 3 and not the entire piece. It matters. So you're squaring the -2, you're squaring the rad 3, and that's how my work by hand looks like that. 2 squared is 4, and then, we just keep doing the math. So your R value is 4. All right. Find your theta using the formula. We have inverse tan of your B value divided by your A value. So what you could do, and you go ahead and try it, go ahead and type in inverse tan, and make sure you are in radians. Inverse tan of 2 over -2 rad 3, hit enter, and see what you get. Hopefully you get something with pi in there. If you don't get something with pi in there, you got to do these by hand. But you know that already. That you all get for your angle. So you type it in, you get -pi/6. Yeah, that sounds right. That sounds right. Your bell work, if you're here for bell work, I went over the domain restrictions, and that's what your calculators are pre-programmed with, and that's why you get this -pi/6 instead of what it's supposed to be. I don't know if I did it by hand. Yeah, of course I did. I did things the hard way. So you don't have to do the stuff by hand like I did. I'm just kind of showing you. If you did it by hand, you would get this. So 5pi/6. And that's because, so remember, -pi/6, what Emily got. -pi/6. All right. So by me doing it by hand, I don't have a correction to do. Emily, you do have the correction to do because of the domain restriction. So -pi/6. If you look at your unit circle, instead of going counterclockwise 30 degrees to get to, well, the radian value, you have to go clockwise 30 degrees. And that puts you at 11pi/6. So -pi/6 is the same thing as 11pi/6. And we want to keep our values positive. Now, here's the problem, Emily. What quadrant is 11pi/6? It is in quadrant number 4. Is in quadrant 4. But we should be in quadrant number 2. So all we got to do is add what to it or subtract what to it. We probably want to subtract it. Yeah. So to avoid going over 2 pi, we should actually just subtract 180 or subtract pi. So you take your 11 pi over 6, subtract pi, hit enter, and you will then get 5 pi over 6. And that means we'll be in quadrant number 2. So knowing to do that builds on our last unit. So remember how the when you have sine, cosine, cosecant, secant, for the general form, it was whatever answer we got plus 2 pi n, but tangent and cotangent, whatever answer you got, it was actually just plus pi n. Well, that relates to this. So we have to subtract that pi. Go ahead.
Quick question. Is it acceptable to just add pi to begin with because it's tangent?
Yes, that would actually work. Yeah. That would work in this case. Yeah, that is fine. And you can do that because 11, so negative pi over 6, we're still in quadrant 4, and it's negative. So we have to be in quadrant 2. So adding a half a rotation to that will make it positive and make it in quadrant 2. So that will work. Yes. You're coming through my speakers instead of my headphones. Let me see if I can fix this. Emily, say something, please.
Hello.
Yeah, it's still coming through the wrong speaker. So, oh, it's because I don't have them plugged in. That's why. Hold on. All right, now say something.
I'm just too powerful for headphones.
All right, it works. Thank you. All right, next, using that information, we're in quadrant 2 with pi over 6. So we just write the answer in the form as either 4 CIS parentheses 5 pi over 6 or that long expanded form. They both mean the same thing. This is fun, right? Yeah, really. So with these, I would say whatever angle you get, if you're in the wrong quadrant, like if you're supposed to be in quadrant 2 and you end up being in quadrant 4, you should be in the diagonal of where you're supposed to be if you are in the wrong place. And whenever you're in the diagonal of the wrong place, all you do is either add or subtract pi. But make sure you stay within one rotation, so from 0 to 2 pi. So just be careful whether you add or subtract that pi to get to the quadrant you're supposed to be. So if if we started in quadrant 1, but what we got, we're in quadrant 3, you would just add or subtract 1 pi. But always check, because you won't always end up in the wrong quadrant. But if you do, it'll be the diagonal one. So you'll be a half a rotation away. And I would say that is always true. Now, if you're in quadrant 2 and what you find is either in quadrant 1 or in quadrant 3, I would say you probably did something wrong, because rather than be in the quadrant that's diagonal to this, you're in a quadrant that is, well, adjacent, right? And I don't, as far as I'm thinking of examples, I can't think of one where that would ever happen, because I don't think it would ever happen. All right, number 2, let's look at this one. We have negative 3 rad 2 plus 3I rad 2. Looking at this, and what quadrant are we in for this one? Is this the same problem? Hold on. Nope, it just looks like the same problem. Okay, it's similar. Yeah, we're in quadrant 2 again. Geez, way to go with variety, right? Quadrant 2 again. Right. Find your R value real quick. Let's give all of you that are here, like, I don't know, like a minute and a half maybe. 1 minute 30 seconds. And then as you do that, I'm going to see if I have better variety coming up. I do. All right, what do we get for the R? Well, we still have another 27 seconds. I'll give you your time. Or in chat, just go ahead and put what you got. Savannah, make sure that you are squaring the entire piece. So make sure you have in parentheses, or you would probably get what you said you got. All right, so the setup should look like this. And again, make sure you have in parentheses. I got 6, but I make mistakes all the time, so you never know. It is 6, because you get, well, I did the work by hand, so there's the work. And so we get 6. All right. So the angle, the setup, you remember inverse tan of your B value divided by your A value. So what goes in the numerator when you do the inverse tan? What goes in the numerator? We read 2. Everyone agree with that? 3 rad 2, yep. 3 rad 2 because it's 3I times rad 2, so we just pull out everything except the I. That is your B value. 3 rad 2 is your B value. So you always put I at the end unless it's a radical. Radicals always go at the very end of a term. Just want to point that out. I don't think I said that ever. All right, and then go ahead and type that in, or you can do it by hand if you want to. I think either way is fine. Oh yeah, that's actually really easy to see, right? It's really easy to see -1. So we need to be in quadrant 2, correct? So looking at the angles in quadrant 2, inverse tan of -1 is what? So quadrant 3 pi over 4. I agree with that. Yeah, 3 pi over 4. That puts us, yep, that would be inverse tan -1. So using our unit circle, there's no correction needed because, well, it's 3 pi over 4. Now, if you typed it in, I believe you get negative pi over 4. Can anybody confirm that? Okay, yeah, Emily got that. So if you type it in, you get negative pi over 4. So you're doing a clockwise rotation of 45 degrees. And that's at 7 pi over 4, right? Or you can leave it like Emily asked earlier. If you're at negative pi over 4, that puts us in quadrant 4. We should be in quadrant 2. All you got to do is do a half a rotation. So you're just adding pi to negative pi over 4. And what is negative pi over 4 plus pi? You hit enter. What do you get? 3 pi over 4. Math is crazy. It's even crazier when it actually works out, right? Yes, 3 pi over 4. So these problems, there's a few ways to look at this. Whether you use the unit circle or you type it in and then you can just add a half rotation to make it positive, and see if we're in the correct quadrant. And if you're not, just add another half a rotation to keep it positive, and it'll put us back into quadrant 4. So, a few ways to approach these and do these. Uh, as long as you get to the correct, well, you're in the correct quadrant and it's the right angle, which it is. So, and once you have those two pieces, we just, well, write it your answer in either form, the shorthand form or the expanded form. They mean the same thing. It doesn't matter. Good. We good. We good. All right. All right. Let's look at these. See, so I have two more of these. Do you want to go through these, or you want me to just show the answer? What do you want me to do? We got about 22 slides, and this is slide number 9 of 22. That's a good question. Where did she go? All right. This coordinate, what quadrant are we in? We are in quadrant 1. Yes. The nice thing about starting in quadrant 1, you can actually use your calculator and you'll always be in quadrant 1. Like there won't be a mess up rotation with quadrant 1. It's kind of nice. Yeah, super easy problems. All right, so we just plug the stuff in for your a squared plus b squared. Everyone go ahead and type that in. Make sure you have it in rad form. Yeah, Neuro has some new features. It's called the bouncer feature. All right, what do we get for the R value? Anybody have an answer yet? So if you got a decimal, it means you need to make it into a radical form. Remember, no decimals. Maybe your calculator can't do it. Dun dun dun. Oh, you mistyped? That would do it too. And if you are sure you didn't mistype, you actually. So depending on the model you have in the FX series, it actually this may be past its ability, or I guess the numbers get too big or too small or whatever. But you may actually have to do these parts individually. So you may have to square this fraction and then write what you get over here. You may have to square this fraction and write what you get over here. And then you may have to type that sum to get the actual sum of those. And then once you have that sum, you can then do the square root of that sum. And that might keep you from having decimal form. So we got 5 rad 3 over 2. That sounds right. 5 rad 3 over 2. Yep, that's what I got to. And there's the work by hand, if you're curious. So I did it in parts like that, like I was describing.
Have we done a problem that's like gonna be on the part two? Like out of the whole unit so far?
Yes, but I already forgot what they were. So after these 2 weeks of Ames testing, I will incorporate TGA bell work problems to kind of review those. They're not bad. No, the problems are pretty easy, I think. So,
Awesome. Thank you.
yep, no worries, no worries. Don't freak out yet. All right. Angle. So we just, you put your inverse tan of your B over your A value, and you hit enter, and what do we get? What sounds muffled? Was Sarah speaking? I did. I already forgot. Sarah and Emily, I think you two sound very similar. All three of you sound the same. I'm sorry. I know, I did. I did. Sorry. All right, what do we get for the angle? Jacob, you still in here? You working this problem out? Give me an answer. Help me out. Rad 3? Radical 3. So this is an angle. How do you get rad 3? Now, oh, you're talking about the inverse tan of rad 3. So what is that angle then? So yeah, so you did the simplifying part. You got inverse tan of rad 3. So what is the angle equal to? Pi over 3. Yeah, that sounds right. And we probably could have typed this in right here and hit enter and skipped all this handwork, right? So typing this in, you should get pi over 3. Now, is pi over 3 in quadrant 1? All right. It sure is. So that's good. And there's your answer. Either the shorthand form or the expanded long form. All right, let's do one more of these. One more of these examples. So I will give you, say, 3 minutes to try to do this entire problem. 3 minutes. All right, one moment. All right, what's the R value here? What's the final answer? How about that? What's the final answer? Rad 11, CIS 2 pi over 3. Let's look. Rad 11. Yep, that is correct. That is correct. And here is the work. Not too bad, right? Not bad yet. I said not too bad. They're kind of all done in a way the same way, right? If you do like, 5 or 6 of them, it's kind of like the same thing. I think I have one more. Let's see. I got 2 more. I do want to go over this problem because you shouldn't actually have one of these on your test. Yeah, you don't. I know for a fact you don't. You might have it on a quiz, I think, maybe. I'll go over it. All right, so the quadrant, so -3 and then up 2, so it's quadrant 2. All right, so we do the R value. We get rad. Is this the same problem as last? Oh, it's not. Okay. It just feels the same. All right, angle. All right, we do inverse tan of 2 over -3. Now, the problem is you can't use your unit circle because it's not it's not like these, where you can't. Yeah, you can. See, so here, if you simplify it, you can use your unit circle, but this one in particular, you can't. It's inverse tan of 2/3. It's not on your unit circle. So you type it in and you get a decimal. You get negative 0.588. All right. So which quadrant is this terminal ray in? Well, this negative 0.588. Now, if you want to convert that radian into degrees to help you like really understand where that is, but that's just over a half of a radian, right? And a half a radian would be 90 degrees. So you're going clockwise just over a half a radian. So which quadrant is that? Which quadrant is that in? So remember, you're going clockwise just over a half a radian. and a half a radian is 90 degrees. So you're going past the 90-degree mark, which puts us in quadrant 3. Or quad. Oh, Chloe's right. And the reason why it's quadrant 4, not quadrant 3, is because this does not have pi. This does not have pi after it. If this was negative 0.588 pi, it would be in quadrant 3. But because pi is already part of that, that's why it's in quadrant 4. So if you think about pi over 2 is 3.14 divided by 2. So that's like 1 point something or other, right? So in order to rotate past 90 degrees, you must be past like that 1 point whatever radians. Easy mistake, right? Because there's no pi there. The easiest way to do this problem is probably convert it into degrees, which you would multiply this number by 180 and then divide it by pi, and that would put it in degrees, which I did right in front of me. I didn't even read it. So negative 0.588 converted into degrees is negative 33.96 degrees, which puts us into quadrant 4, not 3. Yeah. So in the event that you get a problem like this, it's easy to make a mistake because we're so used to seeing pi after it. Convert it into degrees so you can easily understand it. Again, that conversion is multiplying this by 180 and then dividing it by pi. That's how I got this. So we're in quadrant 4. All right. So because we are in quadrant 4 and we want to be in quadrant 2, what should I do to this angle? So yeah, you could add 180 to the degree part of it, but we want to keep our answer in radians. So what should I do to this radian? Add pi to it. Yep. So you would just take this answer here, you would add pi, and then we would then be in quadrant 2. And then that would be the answer. So negative 0.588 plus pi, you hit enter, you will get 2.554. So again, we did Emily's kind of way of understanding this and just kind of, I guess, reduce the number of steps we have to do by just taking this and just adding pi to it to do a half a rotation from quadrant 4 to quadrant 2, which is where we want to be. And that puts us at 2.554. Oh, you were right. You were right. And again, looking at something like this without pi in degree form is probably a lot easier to understand. I think that's what I would do. And that's actually what I did to do this problem. I converted it into degrees to work with degrees before, applying that to the radians. And you could even take this number, add 180 to it. It'll give us the degree that's in quadrant 2. Then that answer, convert that back to radians, and you will get this answer right there. 2 ways to approach it. And to avoid using rounded work, because we don't necessarily want to add pi to this, because this is a rounded answer. You want to type this in and take whatever answer you get and add pi to that to get this answer here. We just write our answer. We rounded to 3 places, thousands, nearest thousands. You won't have one of these on your test. I know that for a fact. Your answers will come out in nice pi formats. Nothing tricky like this. Number 6 is very similar. We'll just kind of go through this pretty quick. We're in quadrant 2 at points. We do the math to find the R value, which is rad 17. We do the inverse tan of B over A. So inverse tan of negative 1/4 is negative 0.245. And this is in quadrant number 4. The degree, converting that radian to degrees, is negative 14.036 degrees. So we're in quadrant 4. We want to be in quadrant 2. So all you have to do is take this and then add pi to it. And that will make it positive and put us in quadrant 2. All right, and once you have that, you just write your answer. When doing these problems, make sure you write down the quadrant that you start in and the quadrant that you end up in to make sure that they match. If they don't match, you're either going to add or subtract a half a rotation, which is pi. But make sure your answer is within the interval 0 to 2 pi. All right, we're going to skip these. So converting from from polar to rectangular, you don't have to do. I don't know why I have this in here. I think I started doing it and then I stopped myself. So I'm going to skip these. We don't have to do these. Plus these, there's actually a lot to them. All right, now to the fun stuff. And it's really these. So that beginning of this lesson is the hardest part of this lesson. The rest is like super easy. So multiplying. All right, when you have two complex numbers in polar form, so I have my first complex number and I have my second complex number, we want to multiply these. To multiply two complex numbers that are in polar form, all you got to do is take the R values, multiply those together, and then take your two angles and you add them together. So again, multiplication, you add the angles, multiply the R values. It's really that easy.
Really quick, I just want to mention, there is no I in the bottom equation. You didn't put the I in front of the sign.
I didn't. Okay. Everyone, there should be an I right here. So, yeah, that should be there. Oopsies. I'm going to fix it on my paper or on my screen, PowerPoint, whatever it's called. All right, I fixed mine. Yeah. Make that I italicized. Ah, good enough. Good enough. Yep. All right, sorry. So I got 4 examples here. We want to multiply these. And again, I wrote my examples in expanded form. It would obviously be a lot more pleasant to look at if I wrote both of these in the condensed form. But your quiz, I think, does it this way. Your test does it the condensed form way. It doesn't matter. I was going to rewrite them all, but that would just take too long. All right, so look at number 11 and 12. All right, we are multiplying these 2 complex numbers that are in polar form together. So again, the formula says we multiply the R value. So you do rad 31 times 5. Do that first. Right? And then what do we do to the angles again? What do we do to the angles? You add them. Yep. You just add them. And writing your work in condensed form, it just looks so much easier. I would suggest doing the same thing. So 2 pi over 3 plus 5 pi over 4 to 23 pi over 12. Anybody else agree with that? Anyone else? Yep, Sarah got the same thing, so that's probably right. And rad 31 times 5 is just 5 rad 31. You can't do anything with it other than that. So that's the answer. Super easy problems, right? But the hard part is converting it into polar form. That's going to be the hard part. This is the easy part. All right, number 12. Let me give you, I think 30 seconds should be enough, right? $30 to solve number 12. Ooh, what's the answer? 6 rad 34 CIS 3 pi. I agree. Ooh, got some agreements. I agree too. All right, I'm going to skip these. I think these are like super easy. So let's just go on to the division. I'll come back to these at the very end and just show the work and the answer. Okay. But no worries. No worries. This is a late class. Dinner time for sure. All right, dividing. So when you multiply them, we multiply the r values and you add the angles. Well, when you are dividing two complex numbers in polar form, you divide the r values and you subtract the angles. That kind of makes sense. Right, so I got 4 examples. We'll only probably just do 2 of them. I think once you see 2, you kind of get the idea. So, um, again, I wrote these in expanded form. I just didn't feel like writing them in condensed form. So we have in polar form, 1 divided by the other. So all we do is take that 4, we divide it by 6. Then you have your CIS. And then you take the angles and you subtract. We do pi over 6 minus 5 pi over 6. And what do we get? We get 4 pi over 9. Type it in again to make sure I didn't type it right or wrong. I got negative 2 pi over 3. Okay, typed it wrong. Now for these, if you're wondering if we can have negative angles here, you can. You could also add 2 pi to this to make it positive. So that way you're in the same location, just it's a coterminal angle. That would also work. But I think on your quizzes and your tests, I think they say it's okay to have negative here. You might have like drag the right answer. So if you don't have any negative answers, you would just add 2 pi to this to get the coterminal angle that is positive within the interval 0 to 2 pi. But this is okay. All right, number 15. Let me give you, say 30 seconds again. I'll do 40 seconds. Yes, you can. You have ones. It's just 2 more examples. All right, what is the final answer for number 16? 4 over 5 CIS, 13 pi over 12. Let's take a look. I agree. 4/5 CIS, 13 pi over 12. All right, all right. Number 17 and 18, go ahead and pause the video if you're watching it to work these out, and I'm going to show the answers in about 5 seconds. Then I'll go back to the previous 2 that we skipped. All right, these problems we skipped. All right, everyone. Well, thanks for showing up to this late class. It was totally optional, but yeah. And as always, I hope you learned something. And I'm going to try to have, so tomorrow I'm going to try to have this live session again at 4:30, but it really depends what time I get out. And I was lucky enough to get out early compared to everyone else for whatever reason. So it is possible that this class may start later, like closer to 5 tomorrow. So if you try to get in and it won't let you in, it's because I haven't logged in yet, and I'm on my way home. So, and if you can't show up, you can't show up. It's a late class, but I still want to put these recorded sessions out, whether or not you all show up. But I do appreciate it. All right, I will see you next time.